All right, this is AP Calculus ABB, Unit 2, Lesson 7. We've got quite a few videos going on this lesson. I want to return to our trapezoid rule example. And what we're going to do in this video is we're going to calculate the maximum error, or an error bound, we call it. It's a valid question to ask. If I'm approximating this answer that I'm looking for, how accurate is that answer? Give me a plus or minus figure. And that's the process of error analysis is a whole field of mathematics. And you will find this particular method of error analysis is pretty common. It has to do with finding the derivatives of the original function. The formulas vary from case to case, but there are some common themes among them. You may recall we had the function f of x. F of x equals negative x minus 2, x minus 16, x plus 1. Okay, and we were finding we're estimating the integral from 3 to 15 of f of x dx. Okay, and we found that to be well, I did the integral by hand here, or not by hand, by calculator. So let's pull up our calculator here. So I did the integral from 3 to 15 and I ended up with 4440. So that's the actual value, and we could do that by hand as well. 4440. And we found the estimate, the sum of the trapezoids using the trapezoid rule with n equals what was it? N equals 6, right? The sum of the trapezoids was 4460. So the absolute error is the error of the trapezoid is the observed minus the expected, right? And that's the simplest way to find error, and that in this case appears to be 20. We were 20 away from where we were. But that's only because I have access to the actual value. And very often when we do error analysis, we don't have access to the actual value. We cannot simply subtract the observed minus the expected to see what the error was. And so we need to set some bounds, give me some parameters, some boundaries. Okay? Well, there's a formula for that, and here it is. The absolute value of the error of the trapezoid method is, and I do not have this memorized, and my thought is that if you get a question on this on the AP test, that they will probably give you the formula. That said, I don't hold it out that it might not be possible for them to expect you to know the formula. But I suspect that if they have a question on this, that it's going to give you the formula. But the error bound formula is b minus a, where a and b are the boundaries of integration, divided by 12. Okay, and the derivation of these is another fascinating subject that we won't get into. H squared, where h is the interval. In some textbooks it's delta h. It's the intervals between the widths of the trapezoid sections. And then this strange factor, capital M sub f double prime. Okay, and what this is, mf double prime, it is the largest value of the second derivative of f on the boundary between a and b. Okay, it's the largest value of the second derivative on the boundary. So let's see if we can figure this out here. We're going to figure out the error bound, but we need this MF double prime factor here. Okay, so let's do it. So f of x is, and let's work this out, negative, because to integrate, I could use the product rule, but I think it would be simpler just to multiply these out first. X squared minus 18x plus 32, x plus 1, f of x equals negative, multiply through by x, x cubed minus 18x squared plus 32x, multiply through by 1, and I'm going to stagger it here just to make the math a little simpler. So x squared minus 18x plus 32. Okay, so f of x equals negative x cubed minus 18 plus 1 is minus 17x squared plus 32 minus 18, I think of 18 rounded up is to 20, that's 12, and 2 is 14. So plus 14, double check, 20, 32, good. X plus 32. And now distribute the negative. F of x equals negative x cubed plus 17x squared minus 14x minus 32. Okay, now let's take the first derivative. Luckily it's not too hard. Negative 3x squared plus 2 times 17 is 34x minus 14. And the second derivative, 3 times 2 is negative 6x plus 34. And this is a linear function, and by finding the maximum value of a linear function on the boundaries from a to b, in this case from 5 to 15, is not too hard. And I could do so without a graph, but if you are stuck, you know you can do it with a graph, and look at the graph, look at the function value here. So negative 6x plus 34, negative y equals negative 6x plus 34. And on the boundaries from 5 to 17, was it? 5 to 15. 5 to 15. Okay, and let's view standard here so we can see here. Oh, it's got an exclamation mark here. Why? Oh, because of my notation. Less than or equal to x, less than or equal to. There we go. All right. Now what we're concerned with here on this boundary is the maximum absolute value. The maximum absolute value. The endpoint here is our absolute maximum of 4. But the absolute value without regard to sign, negative 56 has a greater magnitude. Okay? And I could have gotten that just by substituting the upper bound 15 in for x. But negative 56. So we know the absolute value of this, is less than or equal to 56. Okay? And so that's my bounding factor for MF double prime. Okay? Remember, it's always without regard to sign. We're just talking about a plus minus value. How much error can we anticipate? We know it's not going to be bigger than that. Okay? All right, so let's figure out our formula now. I think we've done the hard work. Okay, let's bring this down over here. Okay, and let's work it out. Work it out. Okay, so the error of the trapezoid, b minus a, 15 minus 5 divided by 12. Or 15 minus, it's 15 minus 3, isn't it? Yeah, it was 3. Okay, yeah, 15 minus 3. I can't read my own writing. 15 minus 3. Terrible. Over 12. And then h h is 15 minus 3 divided by n, which was 6 in this case, squared, and then times 56. Don't forget the squared there. That's a very important factor. I've done that before. This is the voice of experience. 15 minus 3 is 12. Divided by 12 is 1. 15 minus 3 is 12. 12 divided by 6 is 2. 2 squared is 4. 4 times 56 is 224. And so the error of the trapezoid method has to be less than, the magnitude of the error has to be less than or equal to, and this is the maximum error, has to be less than or equal to 24, or 224. Okay? And is 20 our absolute observed error less than 224? The answer is absolutely. Absolutely. So that's how you do that. Hopefully that helps. That second derivative, and if you find the error formula of Simpson's rule, there's a fourth derivative, so that's lots of fun. But if you have trouble finding the maximum or minimum value, try graphing it. You can often make a lot of sense out of it when you graph.